Hey, you want to win some money? Yeah, I know you do. I got a card game over here. It's called 3-Card Monte. All you gotta do is follow the queen. Just watch those cards carefully now. Which one is the queen? Aw, dang, you lose. Okay, let's play again. You can win your money back. Just watch those cards more carefully this time. Which one has the working DDR3 controller IP? You lost badly that time. It's okay. Try again. Put some more money down. Let's see if we can get you some nice USB 3.0 and maybe your job back. Hi, I'm Amelia Dalton, host of Chalk Talk. Does licensing third-party IP for your design make you feel a little bit like you're a mark in a street hustle? It can, can't it? The IP industry has some shady history, and getting reliable design blocks from a reputable company can be a key to success in your SoC projects. Luckily, Cadence Design Systems, a longtime leader in the EDA industry, has been building a strong IP offering that can help with some of your toughest design challenges. In this episode of Chalk Talk HD, I'm talking with Kevin Yee from Cadence about Cadence's big move into IP. Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic. Thank you so much for joining me today, Kevin.
Hi, Amelia. Thanks for having me.
So Cadence is a big player in the EDA market, and I think we all know you guys have design tools. But what's new with Cadence these days?
Actually, there's a lot going on, and I'm glad you asked, because in the semiconductor market, Cadence has always been known for their EDA tools.
Yeah.
And really what we want to focus on right now is a new area that's not so familiar with our customers, which is IP, intellectual property.
Great, okay. So for those of us doing SoC design, things seem to have gotten a lot more complicated, haven't they?
Yeah. Years back, when SoC design started, it made a lot of sense. Designs were running at megahertz speeds.
Yeah.
Million gate designs for SoCs were pretty common, but it was reasonable. You had 18 months, 24 months to do your design.
Sure.
And the design teams that you were given, it was manageable. The task matched the teams that you had. But things have kind of changed in recent times.
Yes.
SoC designs are getting bigger. They're getting faster. It used to be you're using 1 or 2 different IPs. Now you could be using anywhere from a dozen to 20 to 30 different IP blocks.
Sure.
Designs have moved from the megahertz speeds to the gigahertz speeds. Instead of million gates, you're talking about gigagates of logic now.
Right.
And because it's so expensive, it becomes more critical that first silicon has to start working, or it's going to cost you millions of dollars.
Very true.
And at the same time, things that used to take you a year and a half to 2 years, they're asking you to do 6 months to 9 months. But they haven't grown the engineering teams at all. And if anything, your engineering teams have shrunk.
Right, yeah.
The beauty of that is it gives us an opportunity to bring productivity to the design engineers. And we believe that is done through IP and VIP. It brings balance back into that design. It enhances the design teams to give them a lot more productivity so they can address those time to market pressures, those short schedules, the large designs.
Okay. So I've always been a bit skeptical about using third-party IP in my design. You kind of never know what you're going to get. How is Cadence's approach different?
That's the big focus for Cadence right now, is to really introduce a new type of IP, what we call IP Factory.
Okay.
And we call it IP Factory because what we want to do is really do it different than the way it's been done. We want to architect for efficiency, quality, focus on integration, and integration is a big issue right now.
Yeah.
So if we look at how it used to be done, and this is my thing, is I've always believed in IP, and I've been in the industry a long time. If you had a laptop and you had a garage, people claimed that they had IP.
Sure, yeah.
And that's true, but it's a big issue. And we look at the old way as kind of like the flea market.
Okay, yeah.
When you go to a flea market, you're on the hunt for something. And every now and then you're going to find that jewel that's some artifact or something that's worth a lot.
Right, yeah.
But most of the time, it's just a lot of junk. Someone else's junk that you're picking up.
Right, yeah.
So from that model, you never really know what you're going to get. Then if you go to the other extreme about how IP has been addressed, is it's really what we call like the mega store.
Sure, okay, yeah.
You know, Think of the Costco model. They have lots of things. They have everything today. Everything's prepackaged, but what you see is what you get on the shelf.
Yeah.
So if I'm buying lunch and I just need a small bag of chips, I'm forced to buy the 50-pound bag
Right.
because that's what they have.
Yeah.
But if you're doing a big party and the 50-pound bag is what you want, then it's a great fit.
Sure, yeah.
But if you're just looking for lunch, kind of an overkill. Our new thing is what we call IP Factory. It's having lots of IP, but having the ability to configure and customize that solution. So if I'm buying lunch, I can buy a small bag. If I'm having a party, I can buy a big bag. Really architect it to what you need. Don't overkill it, but don't under-service it.
Right.
And if you look at our model, I look at it like Nike.
Okay.
Today, Nike, you can go online, choose what color you want, choose what fabric you want, even have your name put on it if you want.
Yeah.
And really, that's kind of the model that we're going after with IP Factory, is to build to order, really fit into your design and make it easy to integrate.
So, unless you've been living under a rock for the last couple of years, you know that you guys have been quite on a buying spree.
Yeah, we have. It's been a good thing. And part of that is really we have been making bold moves in the IP market and really growing our IP team. And that's really to address the needs in the market today. Years back, we made an acquisition of Denali that really launched us into the IP market. And we have been known in the industry as the memory leaders for DDR. Most recently, we've made some major changes to fill our portfolio to address the customer demands out there. We made an IP acquisition for technology from a company. We've expanded our analog team to grow that capability because the analog and the PHYs have becoming a much more critical part of the SoC design.
Sure, yeah.
We acquired a company called Tensilica that gives us very unique IP that no one else has right now. And I'll talk about that a little bit more later. A company called Cosmic Circuits has joined us as well. And they bring a lot of analog mixed signal as well as mobile IP to us. And then lastly, a company called Evatronics, which kind of fills in a lot of key controllers and logic that we need with USB. Everyone knows USB, and you kind of need that for everything.
Yeah.
But then also things like for memory interfaces for SD, SDIO, eMCC.
Right. Okay. So, Kevin, that's a lot of companies. How does this all fit together?
Well, what we've done is it's just not a bunch of different companies. We've been very intentional about what we've brought in as part of our team. If you look at what Cadence had before, we really had a strong portfolio with memory, as I mentioned, with PCIe, with Ethernet, very common IPs that everyone needs. We had a strong AFE, analog front end, that supports a lot of that mixed signal. Well, we handle the high end of that. With the addition of Cosmic, what it does is they bring us a lot of AFEs at the mid and low range. So instead of being much more cost competitive, things that were more commonplace. Also, they brought a lot of things in the mobile, which is critical. Mobile phones is the hottest area.
Indeed, yeah.
So there's a standard called MIPI, and they bring us the PHYs for that, M-PHY and D-PHY. And they also bring us the PHYs for USB, which are very critical.
Yeah.
In addition to Cosmic, I mentioned Tensilica. And actually, Tensilica is very unique in that it's what they call a DPU, Data Plane Processing Unit. Think of that as a trade-off between offloading your CPU. So a lot of people do everything in CPU and you have software running there. You can actually offload that into the Tensilica DSP block or DPU block, and then the CPU handles the control logic. The Tensilica handles the data plane.
Gotcha, okay.
And they have very unique IP that addresses very specific things in baseband, in audio, in display. So what it allows you to do is accelerate your design, give you better performance, lower your power, and overall give you a better system solution. And that's really what we're focusing on all of these things. And the last thing would be Evatronics, which is the addition of some of our controllers for mobile. We focus a lot on mobiles with MIPI Slim Bus, but they also have our USB controllers and SD, SDIO, eMCC.
Okay.
So what we found is the combination of all these companies that we've really looked at gives us ability to offer our customers the ability to really customize their IP, gives them the ability to really trade off your hardware and your software. And that's really what you want to do when you're doing software.
Right.
You want to look at the system. It's not about just one IP. It's look at how does the whole system work. And we've really listened to our customers to say, what do you need?
Okay, Kevin, well, this sounds nice, but what do you really have? Do you have what I need?
Yeah. So we've put together a very strong portfolio now. And if you look at our list now, we can address almost anything in the memory and storage.
Okay.
We were the leaders in DDR, so we have everything from DDR1 to DDR4. We were actually the first to come out with the DDR4 IP.
Wow, okay.
LPDDR to address the low power. We have that with LPDDR1, 2, and 3, and we'll probably be the first with LPDDR4. Wide I/O. I think we're the only ones that have silicon proven for wide I/O, which is the next generation. And then we're looking at a lot of the next generation technologies as well.
Very nice.
Same thing with NAND. We offer everything that supports on-feed, the key interfaces to memories that are supported by key memory guys like Micron or Toshiba or Samsung.
Okay. Right.
More importantly, the interface things, PCIe, Ethernet, MIPI, USB. We can support a combination of their controllers and their PHYs. And then, as I shared earlier, we have a very strong analog mixed signal, everything from ADCs to DACs to power management to DLLs, PLLs, oscillators, power converters. And the goal is not to just have a bunch of different IPs in different categories, but if you look at the bottom, it's really about subsystem IPs. It's putting it together and pre-integrating it.
Right.
Because if I pre-integrate it and I know that certain things already go together, that's just less work for you to do.
Absolutely.
And then you don't have to test it out because you know it works already.
Right.
So really, the goal is how can we help you be more productive?
Fantastic. So everything you're saying sounds really good, Kevin. But the reality is when I'm doing my design, IP can be really hard to use.
Yeah, what we found listening to customers is when you get IP, a lot of them will say it was more work using your IP than designing it ourselves.
Right.
Or the other thing is, well, I got your IP and I had to redesign my SoC around your IP.
Right, yeah.
Rather than put your IP inside the SoC. To address that, we've architected our IPs to make sure that we give you a lot of customization in the IP.
Okay.
And then one example of that is our PCIe. If you look at our PCIe IP, we have scalable bandwidth. So if you look at the PHYs, we can decide how many PHYs you have on it, how wide it is, how many lanes you're going to use.
Okay.
We can configure the interface, whether you have AXI on it or DMA, or how wide the bits, 32 bits, 64 bits, 256 bits.
Right, okay.
Another thing is we have tunable performance. So we can decide how low your buffering is to make sure we optimize the throughput of data coming through.
Nice, okay.
We have virtualization support. We can do multiple configurations to support root complex or endpoint or dual mode that supports both going directions.
Okay.
And then we also optimize it for area and make sure it's power efficient. So as I talked earlier, is we don't want to overkill, but we don't want to underserve either.
Right.
By allowing you to do customization, we give you that scalability, that customizability, as well as the high quality that you'd expect from the IP.
Kevin, that's great for PCIe, but what about DDR? Let's talk about that.
So what we've done is our whole idea of IP Factory is to do that across all of our IPs, to give you that flexibility, that customization. So another example is DDR. And everyone needs a memory controller because everyone connects to memory today.
Right.
You buy your laptops and it tells you how many megabytes of memory you have, and the more you have, the better. Well, a lot of that's what DDR is about, is if you look at it, we actually have a controller that has multiple clients, so you can actually share the memory. So if you
Nice.
today you have multiple CPUs and they all have to access memory.
Right.
We give you the ability to support multiple CPUs or DSPs or codecs. It can be 32 bits or 64 bits or 128 bits. So that's one way that we can allow you to customize. The other is on your local bus, and the interface is AHB, OCP, AXI, a variety of things. So we connect to whatever CPU you're using.
Okay.
Another way we do it is, again, tunable performance, and everything's about how fast it can run or how good it is.
Sure.
So we give you things like priority engines and arbitration, so you can decide which CPU has access first. We do pipelines to make sure that we reduce latencies, and we also offer you optimized features like BIST, built-in self-test, to make sure everything's okay, ECC. So it's really about the quality of the data coming through.
Nice, okay.
We offer a low power option, which is critical because a lot of this goes into mobile device and consumer devices that are running on battery.
Right.
We also have a configurable PHY interface. So if you're using external PHY, we can connect to almost anything that's out there. We have scalable bandwidth, so anywhere from 8 bits, 16 bits, up to 72 bits if you want.
Okay.
And then we support multiple DDR standards. And the beauty of that is it gives you a lot of flexibility. Most of our customers won't just use one.
Right.
And the reason for that is the memory changes and prices change. So a lot of our customers will say, oh, I want a controller that supports DDR4, DDR3, and LPDDR3. Or LPDDR3 and LPDDR2. And what it does is it gives you the opportunity to say, hey, memory prices have dropped for this. So
Right.
today, LPDDR2 is the cheapest, and I'm going to put that in there. but I can swap it out when LPDDR3 prices drop, and then I can offer a product out there that is higher performance and you haven't had to do a whole new chip design.
Yeah. So, Kevin, customization sounds great. Your examples sound good, but it's not just about one IP. When we build our design, we generally need a whole host of IP. It's about the bundle of IP we need.
Yeah. And that's what we're learning the most about right now, is that as a customer is not about one IP, but when you're building a chip, is targeting a specific application.
Right.
And so what we're doing is we're looking at those applications and really understanding what do you need for those applications? What are the key characteristics? And what can we offer as a complete solution in IP? So if you look at example for the mobile, the protocols that you would be using is DDR, USB, PCIe, possibly MIPI, NAND, so forth.
Sure.
And then what we've done is we looked at, in that market, these are the protocols that you use. This is the IP that we can offer. We can offer you an LPDDR controller and an LPDDR5. We can offer you MPCIe controller and an M-PHY. We can offer you the NAND flash controller and the PHY. So we're really looking at the whole system for you and how we can make it more productive for you.
Very cool. Okay, so Kevin, walk us through a couple examples.
Okay. The first one is the most obvious, mobile. Everyone's,
Sure.
and it can debate it whether the iPad minis are mobile or not. But
Yeah.
but really, you're talking about applications like mobile phones that it's really about low power. You want
Yeah.
small area efficient because things are so small and they're portable.
Sure.
And in those applications, there's a set group of IP that you would be interested in that don't add any necessarily new value because they're industry standards. So we provide that to you so that you can focus in on your crown jewels, your special sauce to make your
Right.
chip different. PCIe is PCIe.
Yeah.
A DDR is a DDR.
Sure.
Now, yes, quality changes and you need to take that into consideration, but the specification itself is going to be pretty common, business and industry spec. So we've looked at it for mobile, and it would be DDR, LPDDR, PCIe, MPCIe, M5s, MIPI, USB that you would want. But if we shift and you look at a different application like consumer,
Okay.
it really uses a subset that might change.
Right.
In mobile, you're really concerned about low power. In consumer, I would say one of the critical things is connectivity.
Sure, yeah.
In consumer product, everyone wants to be connected to the net.
Right.
So whereas in a mobile phone, I probably won't have Ethernet, I will in a consumer application because I want to connect it. Today, consumer applications range to your refrigerators that have internet connection to your refrigerators.
Right.
And the next thing could be your toaster, you know? So we looked at that. A lot of things would be the same in terms of memory, but some things would change. I wouldn't put PCI 3 in a mobile device, but I would in a consumer device.
Right.
If we shift to cloud applications, which actually is on the other end of it, it's really about high bandwidth and high performance. It's throughput, it's servers, it's network storage.
Right.
Everything is about how fast can I do it.
Yeah.
So example of that is I would go to DDR4 or DDR3 or DDR4 for the performance.
Yeah.
I would use PCI 3 or PCI 4, which is the next generation of PCI, because it's all about throughput. Each generation tries to double the throughput or the speed or something else.
Right,
You
yeah.
know? Whereas in the consumer applications, I'm going to focus on 10, 100, 1000 Ethernet. In the server space, I might be focusing on 10, 40, or 100 gigabits.
Yeah.
10 to 100 times faster.
Right.
So those are the kind of things that we're doing at a application and a market level to really understand what your needs are and how you need to address it with the right IP.
Fantastic. So, Kevin, interface IP makes total sense to me. But what about Tensilica? How does that fit into the picture here?
Great thing. Tensilica is a very unique IP that really no one has. And what it is their DPU is a data plane processing unit, and it really addresses the throughput of data, not on the control plane.
Okay.
The Tensilica gives you the opportunity to do your own DSP functions, but we've also optimized it in vertical to address the same thing that we talked about before for particular applications.
Yeah.
Like audio. We have audio codecs can be done, or baseband, or image and processing or displays. So what it does, it allows you to offload the CPU and be a coprocessor,
Oh, okay.
give you better performance
Yeah.
and lower power.
All right, that makes sense. So putting third-party IP in our design requires a whole lot of trust, Kevin. Why should we believe Cadence is going to provide us with the IP we need?
Bottom line is a lot of people ask us questions about what are your difference, how do you test it, and everything else.
Sure.
And we can provide characterization reports, we can show our methodology. Bottom line is it's about having real silicon, and that's how you really judge quality.
Yeah.
We were the first with DDR4, LPDDR3, first with wide I/O. We were first with a lot of things. that's great. But really what it comes down to is we have a lot of design wins. We have a lot of customers that have gone into production and they have working silicon. And I think that's the best judge of how good your IP is going to be.
I think so too. So what's coming down the pike? Obviously, this isn't the last we're going to hear from you guys.
We're always on the move. We're always looking at next generation and what we have to do for the leading edge customers. We want to be able to enable our customers for the next generation SoCs. So with PCIe, we are the first to announce MPCIe.
Okay.
We're looking at PCIe 4, which is just in the specifications and hasn't been released yet. Same thing with the memory, WAD-IO2, HMC. The next generation of USB, everyone's familiar with USB 3 now. You can go to Best Buys and buy it.
Right.
The next generation and they're thinking about changing the name, but it's right now USB 3.5, which has jumped from 5 gigabits to 10.
Wow, okay.
And then on the analog, significantly higher speeds at 25 and 28 gigabits.
Very nice. So this was quite a lot to cover today, Kevin. Let's circle back and recap a bit.
Yeah, so our goal here is really just to introduce you to Cadence IP. Okay. Everyone's familiar with our EDA tools, but we want to really focus on the fact that we're more than just EDA. We're building a new type of IP factory. We're market focused, looking at the different markets and the applications. We're really focused on making sure the quality is there and that it's productive for you. We have integration optimized IP for you. As you've already seen, we've been on a buying spree.
Yes.
But a very intentional one. So we've been growing and expanding very calculated to what the customers need to address the market needs. We've done it organically as well as through acquisitions. We're looking at both engineering and at technology. And we're looking at really where the next generation of IPs need to go to service this market.
Great.
I think most importantly is we're trying to drive the ecosystem. We're trying to work with you as customers. We're working with our foundry partners, our tools partners, and we're really trying to deliver value to this marketplace.
Fantastic. Well, I think that's all I have time for. Thank you so much for joining me today, Kevin. It was a pleasure speaking with you.
Thank you very much for your time, Amelia.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.